Here we have another statement circled in red. If x divides 30, then x divides 105. And we need to find values for x that make this statement true. So as with the previous two examples, we can think of this as the statement P, this as the statement Q. And to get started, we might as well start with our truth table definition of P implies Q. P, Q, P implies Q. All right, we want statements that make it true, so we can eliminate this row that makes where things are false. And this shows us that to make it true, we need either values of x that make P true and Q true, or we can just look at values of x that make P false. Now in the homework, you really just have to find a value for x that makes the statement true. So you could do either one of these. You could find P and Q both true, or you could find just P false. But because this is fun, let's look at this first situation, trying to find a value of x that makes P true and Q true. All right, so a good nice way to do that is to look at the prime factorizations of 30 and 105. Okay, 30, this is 15 and 2, 5 and 3. So 30 is 2 times 3 times 5. I've never seen that do that before. Okay. 105. Let's see, well, 105 ends in a 5, so we know it's divisible by 5. Anything that ends in a 5 or a 0 is divisible by 5. Okay, now how many times does 5 go in there? Meaning, what is that, right? Well, let's see, whatever that is, right, you'd have 105 is equal to 5 times that thing. So that means that that thing is 105 divided by 5. All right, so let's do that division now. Oops. Let's see, 2 times, you get 10, you subtract, bring down the 5. You can see that it's 21. And 21 is 3 and 7. So 105 is 3 times 5 times 7. All right, and so now you can immediately see a few different things that will divide evenly into 30 and 105. Notice what they have in common, right? They have 3's in common, so 3 divides evenly, or 3 divides 30 and 105. They have 5 in common. They also have 3 times 5 in common, otherwise known as 15. So let's just go with 3. Okay, so so 3 divides 30, right? Remember, what does this mean by the definition? This means that (30 over 3) is a whole number. And in fact, that's true, right? That's 30 over 3 is 10. That's an integer, so it checks out. So 3 does divide 30. Let me write this differently. Let's say P is 3 divides 30. Well, that's the same as saying that 30 over 3 is an integer, and that we know is true. 30 over 3, that's 10, which is an integer. Q is 3 divides 105. So that's 105 over 3 is an integer. And that's true as well. Now maybe you're not convinced that 105 over 3 is an integer, so let me show you how that works. 105 over 3, right, remember 105 is 3 times 5 times 7. So in fact, that is an integer. So in fact, we do have true there. Okay, so here we found 3 is an x. So x equals 3 is an example of a value of x that makes this statement true. 3 divides 30. Right, this is because 30 over 3 equals 10. And 10 is an integer. And 3 also divides 105. This is because 105 over 3 is 35, and 35 is an integer. So this is also true. So we have true implies true, and we found something in this situation. All right, now let's continue our fun and look for something that makes P false. So what's something that might make P false? Well, looking at the divisors, right, or not the divisors, the prime, looking at the prime factorization of 30 here, 2 times 3 times 5, let's just pick a prime number, or really any number that's not in that list. Let's say 7, x equals 7. Okay, well then 30 over 7, right, let's see, what is that? 7 times, so that'd be 4 and, let's see, it's 28, 4 and 2 sevenths. 4 and 2 sevenths, not an integer. So 30 over 7 is not an integer, so that tells us that 7 does not divide 30. Well, if 7 does not divide 30, then that means that P, which is 7 divides 30, is false. And so P is false, so no matter what, we always get true. So x equals 7 is a value for x that makes the statement true. Remember, if you have false for the P, false for P, the statement P, then the overall statement is true because you void the contract. All right, so now let's look for values of x that make this statement false. Okay, so now false. All right, so let's see, 30 we found was 2 times 3 times 5, and 105 was 3 times 5 times 7. So what we need is something that divides 30 but doesn't divide a 105. Can you see it there? That's right. Let's choose 2. Let's choose 2 as our x value that divides 30 but doesn't divide 105. Right, so 30 over 2 equals 15, this tells us that, right, and 15 is an integer. Right, 30 over 2 equals 15, and 15 is an integer. This tells us that 2 divides 30. Now, 105 over 2, right, this is not going to be an integer, right? This is essentially because 105 over 2, this is 3 times 5 times 7 over 2, and 2 doesn't go into 3. 2 doesn't go into 5. 2 doesn't go into 7. An even or a whole number amount of times, right? So this is not integer, which says that 2 does not divide 105. So P, which is 2 divides 30, is true. Q, which is 2 divides 105, is false. And we have true implies false, which gives us false. So 2 is a value of x that makes this statement false.